everyone, welcome back. In this video, I'm actually going to be going through some of the practice questions that were previously assigned. This is a special request video from a particular student who just asked, who said they were struggling with these questions and asked if I would do a video going through them. So that's what I'm doing here today. So this was the page 327 assignment, 6BD, 7A, and number 20. So these were the equations with variables on both sides and fractions. So starting with 6b, we had 1 over 3y minus 1 over 2 equals 1 over 6y. Okay, so first thing you always want to do when you have variables on both sides is begin by bringing your two variable terms together using addition or subtraction. So we want to move it over from the side that has two terms to the side that has only one term. So right now, because there's no integer sign here, that means this is a positive. So the opposite of plus 1/3 y would be minus 1/3 y. Okay, remember we use addition or subtraction in order to move the whole term. We're not just canceling the coefficient out here, we're moving the whole thing. So that's what we got to do. So that's gone from there. But then I've got to do the same thing to the other side of my equal sign. So I go minus 1/3 y. As these are, we cannot subtract them. We have to have common denominators. Okay, so I can multiply 3 by 2 to get it to 6, but then I have to do the same thing to the top. So off to the side here, I end up with 1/6y minus 2/6y. Okay, so coming down a line now, this is gone, but my subtraction sign still stands. So I have to treat that as a negative. So on the left side of my equal sign, I have negative 1/2. On the right side, let's go ahead and subtract this. So denominator stays the same. So I'm doing 1 minus 2, or in other words, 1 plus a negative 2. So the negative is stronger by 1, and it's still a y term. So there's what I end up with. Okay, now that they're on the same side, now I can go ahead and get that y alone. Eliminate this numerical coefficient here. So y is currently being multiplied by negative 1 over 6. So opposite would be to divide by negative 1 over 6. Negative 1 over 6 divided by negative 1 over 6 gives me just 1y. That's looking good. That's what I want. But then, of course, I must do the exact same thing to the other side. Divide it by negative 1 over 6. Dividing fractions, kiss and flip. Keep the first fraction the way it is, then comes your kiss. Second fraction, aside from the negative, gets flipped over. Top times top, bottom times bottom. So let's see here. Y is equal to negative times negative, match makes positive 6. 2 times 1, 2. Improper fraction, don't want to leave it like that. But the nice thing is it divides out nice and evenly. 6 divided by 2 gives me 3. So final answer, y is equal to 3. And it looks like this question does ask us to do a check. So let me show you how that would look. Hopefully I won't run out of space here. So remember, check, you're always back to using BEDMAS. So I'm going to copy out my original equation. The only thing I'm going to be changing is anytime I have a y, I will be replacing it with brackets and the value that I got for y here, 3. 3 wholes, so I'm going to put it over 1. So 3 over 1, 3 over 1. Okay, ready. So, brackets first. Nothing for me to solve in these brackets. I'm just using these brackets to show multiplication. No exponents. division or multiplication? Yes. I've got multiplication right here, multiplication right here. So 3 times 1 is 3. 3 times 1 is 3. That's a whole. Minus a half, I'm not dealing with that yet. So just bring it down. 1 times 3 is 3. 6 times 1 is 6. Okay. So what have I got here? I've got a whole minus a half. And what have I got here? 3 over 6. That's also a half. A whole minus a half. Is that a half? Yes, it is. If I have a whole pie and I take away half, I still am left with half. So 1/2 is equal to 1/2. So just like that, I know for sure my answer is correct. Okay, next question. 6D now. I've got negative G equals 2.5 G minus 3. Okay, so first thing, variables on both sides, that's no good. We need to move them to the same side. So we're going to go, ooh, you know what? Even before I do that, mixed number, I don't like that. Mixed numbers are very hard to work with. Change it to improper fraction. So 2 times 2 gives me 4, plus 1 gives me 5 over 2, G minus 3. Okay, so now let's move this variable term to the other side. So no integer sign means it's positive, so the opposite would be to minus 5 over 2G. So then that's gone. But I have to also minus 5 over 2G from the other side of the equal sign. So here's what I end up with. So just keep in mind that if you have no numerical coefficient, that means it's the invisible one. So that would be a negative 1 over 1, because you can put any whole number over 1 to make it a fraction. G minus 5 over 2, G equals, this is gone, so just negative 3 there. Okay, as these are, can I subtract them? Nope, but I can go times 2 times 2. So this would actually end up becoming negative 2 over 2. Now I can subtract them. So I've got 2 negatives combined with 5 more negatives, so that's negative 7 over 2G total. And on the other side of my equation, not doing anything there right now. There we go. So I've now moved my two variable terms together, and I'm left with that negative 7 over 2G. So now, let's get G alone. G is currently being multiplied by negative 7 over 2, so we're going to divide by negative 7 over 2. But then we got to do the same thing to the other side, divide by negative 7 over 2. This whole, let's make it a fraction over 1, so that we're dealing with two fractions. This divides out to a single G. That's good, that's what I want. Keep, kiss. And the second fraction gets flipped. Let's actually multiply this. Negative times negative makes positive 6. And 7 times 1, 7. Can't reduce that at all. It's not improper. So I can simply go G is equal to 6 over 7. Box it up. Final answer. So for my check, back to using BEDMAS, copy this out, whoops, except the one thing I'm replacing is my variable. So the check is a little bit tricky because we do have a negative G, and you got to remember that that negative on there counts as a numerical coefficient. So we have to leave the negative. The only thing we're replacing is just the G. So we've got negative and then the 6 over 7 there equals, and I'm going to leave that mixed number in improper form for my check too. It's never fun working with mixed numbers, so I'll do that. Oops, I keep writing G out. That's supposed to be times 6 over 7, the value that I got for G. And then minus 3. Okay, so according to BEDMAS, I need to do multiplication first. Okay, so this negative 1 times 6 over 7 is just going to turn 6 over 7 into a negative. 5 times 6 gives me 30. 7 times 2 gives me 14. And then minus 3. Okay, so that takes care of my multiplication and division onto addition or subtraction, which is just this part here. Fraction minus whole, don't like it, but easily fixed by putting my whole over 1, and then we can make a common denominator by timesing by 14. Okay. So here's what we end up. So we've still got this negative 6 over 7 on the left side of the equation. And now we've got 30 over 14 minus 42 over 14. Okay, so now we can actually go ahead and subtract these numerators. Okay, so positive minus a bigger negative, that's, we can do keep, change, change. So we have 30 plus negative 42. So definitely end up with a negative number there. And it would be 42 is bigger than 30 by 12. Okay, so our last step is just to make sure these are equivalent fractions. So if I divide negative 12 by 2, that gets me to negative 6. Does dividing 14 by 2 get me to 7? Sure does. So check, I know for sure that that's correct. Okay, on to the next one. I need another paper here, 7A. Okay, so what does 7A say? It says 1/2 n equals 2/5 plus 1/5 n. So first thing, get these variable terms all together. So this is plus 1/5 n, so I need to minus 1/5 n to get rid of it. But then I must do the same thing to the other side, minus 1/5 n. I'm going to need common denominators to actually be able to subtract those. There's nothing I can multiply 2 by, not a no whole number that I can multiply 2 by to get to 5. So instead, I'm going to get it, both of these to 10. So I'm going to go times 5 times 5, and then times 2 times 2. So I'll use 10 as my common denominator there. So I end up with 5 over 10n minus 2 over 10n equals, this is gone, so just 2 over 5. Now I can actually subtract these. Okay, so denominator stays the same. 5 minus 2 gives me 3, and that's still n term, equals 2 over 5. Didn't do anything with that side. Okay, all I've done is I've moved this term over to the other side and subtracted them. Here's where I'm at. Now let's cancel out that numerical coefficient. So opposite of multiplying by 3/10 would be to divide by 3/10. 3/10 divided by 3/10 leaves me with just 1n, but then I have to do the same thing over here. Divide by 3/10. Divide fractions, keep, kiss, flip. 2 times 10 gives me 20. 5 times 3 gives me 15. That's both improper, and there are common factors between both 20 and 15. These are both evenly divisible by 5, so let me start with that. So that leaves me with 4 over 3 3 fits into 4 once with one piece left over. So there's what I end up with. So final answer, n is equal to 1 1/3. Box it up. Nice and neat final answer. For my check though, I'm going to use this 4/3. I want to use it in improper form. Not fun to work with it in mixed number form. That's not going to work. So check, back to BEDMAS. Here we go. My original equation, except that I'm going to substitute what I got for n in its improper form anywhere that the original equation had an n. So you can see I'm replacing the n's just with some wide open brackets here, and then I'll just pencil in this 4/3. Okay, so multiplication comes before addition, so let's multiply these fractions first. 4/6 is equal to 2/5 plus, because I'm not dealing with that addition right now, I'm just dealing with the multiplication. 1 times 4 gives me 4, 5 times 3, 15. As it is, no, I cannot add these, but I can get 5 to 15 by timesing by 3. So let's see, come down another line. I'm not messing with that 4/6, but I am changing this to an equivalent fraction over 15. So this becomes 6/15 plus 4/15. Okay. Oh, I'm going to run out of room for my check here. Whoops. So 6 plus 4, denominator stays the same. 10/15. Okay, so right now I can't divide 10 by anything to get to 4. I can't divide 15 by anything to get to 6. So what we're going to do is we're actually going to reduce both sides of this fraction. So if I divide by 2, divide by 2, the left side of my equation I'm left with 2/3. And here, if I divide by 5, divide by 5, the right side of my equation I'm left with 2/3. Check. Looking good. Okay, one more. So, number 20. The word problem. So it says, Alan's height is 4/5 of his father's height. Okay, so Alan is equal to 4/5 of his father's height, which we don't know what it is, so that's what we're going to call F. Okay, Alan's older brother, Ben, is 6 centimeters taller than Alan. So Ben is equal to Alan plus 6 centimeters taller than Alan. Ben's height, so again we're given another specific of Ben. Ben's height is 5/6 of the father's height. Again, the unknown, our F there. How tall is their father? So that's ultimately what we're trying to find, is the value of F. So we need to put this together as an equation. So we've got two Bens here, so we're going to set up our equation with two representations of Ben's height on either side. So on one side, we can represent Ben's height as Alan plus 6. On the other side, we can represent Ben's height as 5/6 of his father's height. Okay, and then we also have the specifics of Alan, right? So we're going to replace this Alan, 4/5 F plus 6 equals 5/6 F. So there is our equation. Now we just have to do the same steps we've been practicing. So let's move these variable terms to the same side. So minus 4/5 F gone, minus 4/5 F's. Don't have common denominators at the moment, but I can make common denominators. Times 6, times 6, times 5 times 5. That'll do it. So 6 is all I'm left with here, and it's positive, so I don't have to worry about carrying the subtraction down or anything like that. I end up with 25 over 30 minus 24 over 30. Whoops, and these are both f's. Careful not to drop your variable like I did there. That'll really screw you up, so careful, careful. 30, denominator stays the same. 25 minus 24 leaves me with 1. 1 over 30f. Opposite of multiplying by 1/30 would be to divide by 1/30. Same thing to the other side, divide by 1/30. So here's what I end up with. 6 over 1, of course, make them both into fractions. Keep, kiss, flip the other one over. And on the right side, I'm left with just a single f. So all I got to do now is multiply these fractions. Okay, my denominator is going to be over 1, so I can just get rid of that. Okay, denominator of 1, it's like another instance of the invisible 1. We don't need it. Anything divided by 1 stays the same. So I'm just going to do 6 times 30, which gives me 180. So right there, that's my final answer. Okay, but let's go back to the question, because it is a word problem. So it says, how tall is their father? So we should say, Alan and Ben's father is 180 centimeters tall. That's it, final answer. Alright guys, I hope that helped. Thanks for watching. Bye.